That fascinating material from Weatherscene conversations you mentioned, the stuff about thunderstorms. And, it really makes you think about those moments. Hasn't everyone been caught in one? Where the sky just, opens up. You feel completely tiny, but also just awestruck. It's quite something.
Yeah.
So for this deep dive, that's exactly what we're going to get into, right? Thunderstorm.
Yeah. Utterly tiny, but completely awestruck. That really captures it, doesn't it? It's why they're so fascinating. So our mission today basically is to unpack one of nature's most electrifying phenomena, the thunderstorm. We want to understand how these things actually work, what the dangers are, and maybe even, appreciate their surprising beauty.
Right. And we'll break down how they form these huge storms. We'll get into the science behind lightning and thunder, which is frankly mind-blowing. Plus really practical stuff like how to stay safe and what role they play in the bigger weather picture.
Exactly. And thinking about how they work, it's useful to see them almost as like giant engines, vertical engines. They're powered by warm, moist air shooting up from the ground. That's the fuel.
So that warm, moist air rising, is that the main trigger? Or are there other things that kick it off? And what actually happens when that warm air goes way up high where it's cold?
That warm rising air is, absolutely fundamental. As it goes up, it cools down naturally, and that cooling makes the water vapor condense. That's how you get clouds. But for a thunderstorm, you need more. Enough moisture, and crucially, an unstable atmosphere. If you have that instability, the air just keeps going up like a runaway elevator. Creates a really powerful updraft.
Oh, okay. And that massive updraft, that's what builds those specific clouds. Cumulonimbus, these aren't just your average fluffy clouds, are they? I remember reading someone called them nature's skyscrapers.
That's a great description, actually, because they are immense. They can stretch, way up there, sometimes over 12 kilometers high.
12 kilometers. That's hard to picture. Taller than Mount Everest, basically.
A cloud. Exactly. And it's inside these huge, turbulent clouds with those strong updrafts that the next stage happens. That's where you get electrical charges separating, positive and negative. And that separation, that sets the stage for lightning.
Right, the lightning. And I read something about the temperature of lightning that just seemed unbelievable. What was that figure again?
Oh, it's staggering. A lightning bolt heats the air around it to about 30,000 degrees Celsius.
30,000 degrees. Seriously?
Yep. For context, that's hotter than the surface of the sun.
Wow. Okay. That's incredible.
It really is an unbelievable amount of energy in a fraction of a second.
And the thunder, that's just the sound of that heat. The air expanding super fast.
Precisely. The lightning bolt superheats the air channel so incredibly quickly, it expands explosively, like a shockwave. That shockwave is what you hear as thunder.
So that little trick people use, counting the seconds between the flash and the boom, that actually works for figuring out distance.
It does, yeah. Sound travels much slower than light, obviously. So you see the flash almost instantly. Then you count 1,000, 2, 1,000. Divide the number of seconds by 3, roughly. That gives you the distance in kilometers.
Okay, divide by 3 for kilometers. Good tip. And the safety angle there is if the gap is really short, like under 3 seconds.
Yeah, if it's that close, maybe less than a kilometer away, you need to take cover immediately. Get indoors now. Because lightning, beautiful as it is from afar, is incredibly dangerous.
Yeah, the dangers are significant, aren't they? It's not just a light show. I saw some figures. Thousands of wildfires started by lightning every year.
Yeah.
Billions in damages.
That's right. Globally, the impact is huge. Wildfires, damage to property, power grids, and sadly, injuries and even fatalities, too.
And it's not just the lightning itself. You mentioned flash floods earlier. How does that link specifically to thunderstorms?
Well, some thunderstorms, especially if they move slowly, can just dump enormous amounts of rain in a very short time. We're talking tens of millimeters, sometimes more, in less than an hour. In urban areas, with lots of concrete and tarmac, that water has nowhere to soak in.
So it just runs off.
Yeah.
And it overwhelms drains, leading to flash flood.
Exactly. It can happen incredibly fast and be extremely dangerous, especially for drivers or people near rivers or low-lying areas.
And you also said that not all thunderstorms are the same, right? They vary a lot.
Oh, hugely. Some are quite brief, maybe lasting only 10, 20 minutes. A quick downpour, a few rumbles, and they're gone. Others can organize themselves, grow much larger, and last for hours. And then you have the most intense type.
Supercells. Okay, what makes them different?
Supercells have a specific, highly organized structure. The key feature is a rotating updraft. It's called a mesocyclone. This rotation allows them to become much stronger and last much longer than ordinary thunderstorms. And crucially, they're the ones most likely to produce really severe weather, like large hail, damaging winds, and even tornadoes.
Right, tornadoes are often linked to these supercells. That makes sense. It brings to mind that story, I think it was in the Lake District, someone hiking. They described the sky turning this weird greenish-gray color.
Ah, yes, that greenish tinge can sometimes happen with very intense storms, often those with large hail. And the person mentioned feeling the electricity in the air, hair standing on end.
That must have been terrifying, feeling it literally.
It's a sign that the electrical charge difference between the cloud and the ground is becoming extreme, very dangerous. It means lightning is probably imminent. That person did the right thing, getting to lower ground quickly.
It really highlights how fast things can change from just watching a storm build to being right in the danger zone. Which brings us back to safety, the absolute basics.
The number one rule, simple but effective. When thunder roars, go indoors. Find a substantial building or a hardtop vehicle. And stay away from things that conduct electricity. Open fields, obviously. Hilltops. Tall, isolated trees, water lakes, pools, the ocean, and metal objects, fences, bleachers, machinery.
Standard advice, but always worth repeating. What about the all clear? How long should you actually wait after the storm seems to have passed?
That's a really important one people often forget. The danger doesn't end with the last loud clap of thunder or the heaviest rain. Lightning can strike surprisingly far from the main storm core, sometimes called a bolt from the blue. So the standard advice is to wait at least 30 minutes after the last sound of thunder before going back outside.
Okay, noted. Patience is key. It's funny, though, despite the danger, there is something almost calming about watching a storm from safety, like seeing a time-lapse of lightning at night. It's incredibly beautiful in a way.
Absolutely. When you're safely inside, you can appreciate the raw power and, yes, the beauty of it. It's a powerful reminder of the forces at work.
And
in our
it's not
atmosphere.
just about the spectacle or the danger, is it? These storms actually play a role, an important one.
They really do. Despite their destructive potential, thunderstorms are vital for the planet's sort of atmospheric balance. They help redistribute heat, moving warm air from the surface high into the atmosphere, which can have a cooling effect overall. And, of course, they bring essential rainfall, redistributing
So they're part of the
moisture
Earth's
across
natural
landscapes.
regulation system in a way, cooling things down, watering plants.
Exactly. They're a fundamental part of the water cycle and energy balance, a necessary, powerful force of nature.
So wrapping this up then, we've looked at how these massive storms get going, the pretty scary physics of lightning and thunder. We've covered the real dangers, lightning, floods, and the importance of safety rules, but also touched on their surprising beauty and their crucial role in the environment.
Yeah, hopefully we've given you a deeper appreciation. So the next time you hear that distant rumble, maybe approach it with a bit more respect, a bit more understanding of both the power and the purpose
Definitely. It
behind
makes
it.
you think if something as seemingly common as a thunderstorm holds all this incredible power and complex science, what other everyday natural things are happening around us that we might be missing? These huge forces constantly at play that we just don't fully see. Makes you wonder, doesn't it?